Okay guys, welcome back to my channel. Now today we'll be discussing about a very important topic in engineering mechanics. Okay, now this is centroid. Now this centroids go a long way in solving questions involving moments of inertia, okay, of shapes, okay, that will be given to you in your exam. Now what is a centroid? Simply put, a centroid is the distance from the center of a shape to a particular axis, either the y-axis or the x-axis. Okay, it can be called a parallel theorem. I'll explain later. Okay, so it's the distance from the center of the shape to an axis. Now, for example, on the board we have four shapes that are very important in engineering mechanics: the rectangle, the triangle, the circle, and the semicircle. We're going to see the centroids for these shapes in this video. If you've not subscribed, please click on the subscribe button and stay glued to the channel. Now, quickly, for the rectangle, I will say before, the centroid is the distance from the center, meaning we must first locate the center. Okay, so if I say this should be the center of this rectangle, then that is the centroid. Okay, so the distance from the centroid to the x-axis is called the y-centroid, while the distance from the centroid to the y is called the x-centroid. Okay, now recall this rectangle has a base b and a height h. Now, since it is a symmetric shape, okay, the distance from the center to the y, which is the x-centroid, should just be the half of the base. So we can say for the rectangle, the x-centroid is the base over 2. Now, in the same way, the y-centroid will also be the height over 2. Very simple to remember, okay? So it's just the half of the base and the height. Now, for the triangle, where should be the center? Okay, if you locate just a point and say, okay, this should be my center, for example, again, the distance from this center to the x is called the y, and then from here to the y is called the x. Now, the triangle is not completely symmetric, although the base is symmetric. Since the centroid is the middle and this base is from here to here, we can say it is basically the half of the base. Okay, so the x-centroid will just be the base. Okay, here to here is base. Let's look at that. It will be the base over 2, the half of the base for the x-centroid for triangle in this shape, in this form. Now, the y-centroid will not be the height over 2 because we cannot say that this triangle is symmetric at the height. So what do we do? For the y-centroid is actually the height over 3. Okay, so for a triangle of this nature, the x-centroid is a base over 2, but the y-centroid is the height over 3. So this is the centroid for a triangle. Now, for a circle, remember the distance from the center of the circle to touch any part of the circumference is called the radius, right? So if we are to find the y-centroid and the x-centroid from the look of the diagram, we can easily say, oh, that the x-centroid for this circle is the radius and as well as the y-centroid. Look at the board. From the center to the edge to the y, that's radius, and again from here to here, that's still radius. So for the circle, it is just the radius for both the x and the y centroid. Now for the semicircle, okay, we're going to pick a center again. Let's say we'll pick here as our center. Now from here to here is the y centroid, while from here all the way to the y is the x centroid. Remember again, from here to this y axis becomes the radius again. So we can say the x-centroid is still the radius, but the y-centroid is not the radius. Neither is it half of the radius. In this shape, the y-centroid becomes 4r over 3 pi. Okay, so you must memorize these formulas before you can solve questions from centroid. That's the centroid for the semicircle in this orientation, and this for the circle, this for triangle, and this for the rectangle. In the next video, we're going to see which other ways can you be given a triangle and a semicircle or a quadrant, okay, to also find their centroid, because these are not the only ways you might see the shape, okay, but they all look alike and they have the same patterns in getting their formulas. So this will be the end of this video. Thank you very much Don't forget to share to your friends and your classmates. God bless you.